The reflection and transmission at oblique incident. This is a continued lecture, and we know that E naught R and E naught T, we already discussed about this. This depends upon the incident angle theta I, the incident angle theta I, such as alpha, because E naught R and E naught T depends upon alpha, and for already we know about this. So E naught R and E naught T depends upon alpha and beta, and where alpha is equal to cosine theta T divided by sine theta I. So it means that E naught R and E naught T depends upon incident angle. And here alpha, we know about alpha which is equal to 1 minus f. I consider this cosine theta T, and if I write down from sine square theta T plus cos square theta T, which is equal to 1, from this relation I can find out cosine theta T, which is equal to 1 minus sine square theta T under root. And further, this sine square theta T from Snell's law, the Snell's law tells us that sine theta T divided by sine theta I, which is equal to n1 divided by n2. And from this relation, we can obtain sine theta T. So sine theta T will be equal to n1 divided by 2 sine theta I. Putting the value of sine theta T from this relation here, then this alpha becomes n1 divided by 2 sine theta I whole square under root, and this is cosine theta I. Now, if I consider theta I, the incident angle, which is equal to 0, because this is the boundary, and the wave is propagating in this direction, and here the incident angle between this, which is equal to theta I, which is equal to 0, then this is a normal incidence, and for the normal incidence we will have alpha, which is equal to 1. For the another case, if we consider theta I, which is equal to 90 degree, if we consider that the light is incident from this direction, this is the boundary, and if the light is moving in this direction, then it makes an angle of 90 degree. Then alpha will be undefined, because cosine 90, which is equal to 0, then this will be undefined. Now we are looking for an incident angle which is in between 0 and 90. And let's suppose this intermediate angle between 0 and 90, and we call this Brewster angle. And if I denote this by theta B, so this is a Brewster angle. And what is a Brewster angle? Let's define this. When the reflected and transmitted waves are perpendicular to each other, then the incident angle is known as the Brewster angle. How it is possible? Let's make a diagram. if I consider that this is the incident angle, this is the incident angle, if this is the incident angle theta I, which is equal to theta B, which is the Brewster angle, for which if this is a boundary, if I consider this is a boundary, and the ray is incident, and this is the, let's suppose, the z direction, then it will can be reflected in this direction, and this angle is equal to theta r. It may be reflected in this direction, and this angle is known as theta t, and this reflected and this transmitted, this makes an angle of 90 degree. This is a 90 degree angle which makes by reflected ray and transmitted light. From this relation, from this diagram, we can say that this whole angle is equal to theta r 90 plus theta t. Theta r plus 90 degree plus theta t, which is equal to 180 degree. Then theta r plus theta t, which is equal to 90 degree. 180 minus 90. And here theta r is equal to theta b, because the incident angle which is equal to the reflected angle. So theta b, which is equal to theta r. So this theta b plus theta t, which is equal to 90 degree. Now from the Snell's law, from Snell's law, n1 sine theta b, which is the incident angle, which is equal to n2 sine theta t, which is the transmitted one. And here the transmitted angle, we can obtain this from theta t, which is equal to 90 degree minus theta b. So this theta t we can put here. So n1 sine theta b, which is equal to n2 sine theta 90 degree minus theta b. And after using this identity, we can get n1 sine theta b, which is equal to n2 cosine theta b. When you open this identity, you can get cosine theta b. And from this relation, sine theta b divided by cosine theta b, which is equal to n2 divided by n1. And from here, one can get tangent theta b, which is equal to n2 divided by n1, and theta b, which is equal to tan inverse n2 divided by n1. So this is the Brewster angle, the relation of the Brewster angle, that one can easily calculate the Brewster angle if we have the refractive index of one and the second, the refractive indices of the two media. Then one can find out very easily the Brewster angle. Now to know about the power per unit area striking the interface. The intensity is, we know the incident intensity of the wave, II, which is equal to, because it makes an angle of theta, then we can say that this will be equal to 1 over 2 epsilon 1 v1 e naught I square and cosine theta I. So this cosine must be included in the intensity. And similarly for IR, which is equal to 1 over 2 epsilon 1 v1 e naught r square and cosine theta r. And for IT, this must be equal to 1 over 2 epsilon 2 v2 e naught t square and cosine theta t. So these are the powers or intensities. Now to calculate the reflection and transmission coefficients for parallel polarization, using these relations, we can find out the reflection and transmission coefficient. So R is equal to IR divided by II. So this is very easy. We have this and this. Then if we put this and this, we can get if I put 1 over 2 epsilon 1 v1 e naught r square and cosine theta r, 1 over 2 epsilon 1 v1 e naught I square and cosine theta I. So these terms must be cancelled out, and only we can get here theta r and theta I, the incident angle theta I from the first law theta r, this must be equal. If these angles are equal, then this also must be cancelled out, and we can get only E naught R divided by E naught I whole square. And we know about E naught R and E naught I, and this is from this relation already I have mentioned out, that E naught R, which is equal to alpha minus beta divided by alpha plus beta, and E naught I. So from this relation E naught R divided by E naught I, we can have this relation. So putting the value, we must alpha plus beta and whole square. So this is the reflection coefficient, and we can also find out the transmission coefficient. The transmission coefficient IT divided by II. Putting these values, and we can get epsilon 2 V2 divided by epsilon 1 V1 and E naught T divided by E naught I whole square, and also cosine theta t divided by sine theta I. So this is the relation that we can get. If we look and find out this term must be equal to beta, and this term from this relation E naught t, which is equal to 2 divided by alpha plus beta E naught I, from this relation we can have 2 divided by alpha plus beta and whole square. And this cosine theta t divided by sine theta I, we know about this, we have considered this is alpha. So this is the reflection coefficient and this is the transmission coefficient. R plus T, which is equal to, we know about R, alpha minus beta whole square divided by alpha plus beta whole square plus this one alpha beta, and this is 4 divided by alpha plus beta whole square. And from this we can have the LCM, which is equal to alpha plus beta whole square, and this is alpha minus beta whole square plus 4 alpha and beta. And from this alpha square plus beta square minus 2 alpha beta plus 4 alpha beta divided by alpha plus beta whole square. And if minus 2 alpha beta plus 4 alpha beta, we have plus 2 alpha beta, then alpha square plus beta square plus 2 alpha beta, and this is alpha plus beta whole square, so this is also alpha square plus beta square plus 2 alpha and beta, and these are equal and must be cancelled out, and we can get R plus T, which is equal to 1.